this lesson, we're talking about weighted graphs, or sometimes called networks. A weighted graph or a network is a graph in which every edge is assigned a weight. A weight is a number which could represent a distance, or time, or some other value that's assigned to that edge. The weight of a path is found by adding all the weights of all the edges that are included in that path. And finally, a weighted graph can be directed or not. In this example, the network diagram that follows shows the distance in kilometers between towns that are linked by a rail network. Transporting heavy equipment by train costs approximately $100 per kilometer in this example. They're asking, what is the approximate cost of transporting heavy equipment from point G to point M if the train takes the shortest route? Here are the two possible routes. If we're starting at point G, both routes are going to start off the same, going from G to R to Q. But after that, there's a branch in the track, so you have a choice. You can either go from Q to S, and then on to M. You can also go from G to R, from R to Q, and take the other from Q to T, and from T to M. So the question is, which route is most efficient as far as taking the shortest possible distance? Let's look at the red route first of all, from G, R, Q, S, M. That's the path we're going to follow. Now we want to add up the total weight, which is 530 plus 210 plus 240 plus 150 for a total of 1,130 kilometers. The second path in green starts at the same point, G, also goes to R and Q, but then diverges to go through T before getting to M. The total weights for the green route starts off with 530 plus 210 plus 135 plus 150 for a total of 1,025. We've been asked for the approximate cost following the shortest route, so we look at both of these and we determine that the GRQ-TM route is 5 kilometers shorter. Our total cost then, since we've been told it costs $100 per kilometer, it's going to be $100 times 1,025, or $102,500. We'd summarize to say the cost to transport from G to M is $102,500. Try this question on your own, and then come back to watch the solution. Based on this graph, determine the weight of path ABCF. A to B, B to C, C to F. We add up each of the edges. We've got 1 plus 3 is 4, plus 4 plus 6 is 10. So the weight of that path ABCF is 10. Second part of the question asks the weight of circuit CDEFC. C, D, D to E, E to F, and F to C. Again, adding up all of the weights on each of the edges, 5 plus 7 is 12, plus 8 is 20, plus 6 is 26. Try the practice questions on your own, then come back to check out the solutions. Determine the weight of path EDCAD. E to D, DC, CA, AD. Add up the weights of each of the edges along the path. We get 2, plus 1 is 3, plus 4 is 7, plus 6 is 13. Part B asks us to determine the weight of path BCAD. BCAD. Notice that we're following the direction of all of the arrows as we're laying out the path. Adding up the weights of each of the edges, 3 plus 4 is 7, plus 6 is also 13. Next, we're asked to determine the weight of E, A, B, C. E to A to B, B to C. The weights are 9 plus 8 is 17 plus 3 is 20. We're asked to identify all the simple paths going from vertex E to vertex B. So we can see from vertex E there are two directions to start, and we want to end up at vertex B. So let's see, the most obvious seems to be if we go from E to A and from A to B. So one path. Second path, we go from E to D. We can't go back to A, so we're going to continue on to C. Can't go up to B, we have to zigzag back to A. And finally, A to B. So a second simple path is E, D, C, A, B. Now we're asked, of the two paths that were identified, which one has the smallest weight? If we go from E to A, that's 9, to B is 17. So we have to think about that. We'll keep track of that number for the moment. Now let's look at the path that we just did. E to D is 2, D to C is 1, so we're at 3, plus 4 is 7, plus 8 is only 15. So the route with the smallest weight is actually the second one, which is longer, EDCAB. The following graph represents the length in kilometers of various routes Louis could take as he trains for a marathon. He begins and ends each training session at his home, H. For easy runs, Louis wants to run less than 10 kilometers without taking the same road twice. What route can he take, and how long is his run? So starting from home, we have to follow the directed arrows to make sure we're not going against them. Some of them are directed, and some of them are not. So let's start off and just see, through experimentation, what each of the routes gives us. If I go from H to Z, I'm at 4, plus 3 makes 7, plus 4 makes 11. So I've already gone over my limit of what I'm trying to do to get a 10-kilometer run. Let's try another approach. If I go from H to S, it's 1. From S to T, it takes me up to 3. And back to H would be a total of 5. So that's one possible route. We might suggest that Louis run that same route backwards by going H to T, T to S. The problem is when he tries to go S to H, he's going back against a directed edge, so he can't go that route. So running the route backwards isn't a possible solution. As a result, we would say that the route for Louis is H, S, T, H. And it's 5 kilometers. The next question asks, how long is Louis' run if he takes the following route? H, Z, Y, S, V, U, T, H. So let's map that out. H to Z, Z to Y, Y to S, S to V, V to U, U to T, and T back to home. To calculate the total length of the route, we simply add up each of the edges. 4 plus 3 is 7, plus 4 is 11, plus 3 is 14, plus 5 is 19, plus 8 is 27, plus 2 is 29. So the length of the route is 29 kilometers. Question C says Louis would like to run a circuit that covers between 30 and 35 kilometers without taking the same road twice. Is it possible? And if so, what route could he take? We know he has to start at H, so let's try some routes. I'm going to start at H and head down to T. From T, I know I've got to go a long way, so I'm going to keep kind of heading out to U, to V. Now I can't go to W because I'm going against the directed edge, so I'll go back to S. But I run into the same problem here as well. I'm going back against the directed edge, so that doesn't work. Is there another route I can go from S? Well, I could go back to T, but we've also been said that Louis doesn't want to repeat any roads, so we don't want to go back along this road. So it looks like going out in this direction doesn't really work for us because there's only one direction you can go. You can only get out from H that way, but you have no way of coming back. So that tells us we're going to have to use one of these directed edges that heads away from his house as the starting point. So let's see what happens if we head from H to S first of all, S to Y, Y to X, X to W, W back to S. So we can hit the same vertex, but we're not going to repeat the same edge. Then over to T and back to H. Let's see what we ended up with. 1 plus 4 is 5, plus 6 is 11, plus 9 is 20, plus 7 is 27, plus 2 is 29, plus 2 is 31. That gives us a circuit that meets Lewis' requirements. The key concepts and definitions from this lesson are: a weighted graph, or a network, is a graph in which every edge is assigned a weight. A weight is a number which could represent distance or time or some other value that we're assigning to that edge. The weight of a path is found by adding the weights of all the edges that are included in that path. And a weighted graph can be directed or not.